Swayam Prabha. Digital India. Educated India.
Now, having talked about basic understanding of structure of bricks and understanding what type of deterioration processes happen in bricks, let's now look at stone, which we consider to be a more natural material, because bricks anyway, you take natural soil and then you mold it and texture it and then dry and burn it. In the case of stone, you extract it and use it as such, only you may be dressing it to a certain size or shape. Okay? So, stone is quite different as compared to a brick in that perspective. Now, when we try to use stone in very large blocks, typically of the size 1 meter or more, a lot of these large scale buildings, like for example, if you consider the old Parliament House that is there in New Delhi, many of the structures that are there in the capital which form the ministries and so on, Rashtrapati Bhavan for instance, many of these are actually made with very large blocks of stone, and these blocks of stone are called dimension stone, 1 meter type size of stone blocks which are used for construction. These are called dimension stone. Now, of course, people started realizing the productivity was improved a lot more by reducing the size of the blocks. Now, if you think about the oldest structures that you can imagine in stone, like the pyramids of Egypt, the stone blocks there are massive. They are a few meters in size, and it must have taken quite a bit of effort from the workers to actually carry this and put this in place. Okay? But today, we realize that we can actually bring in a lot more advantages of using smaller blocks and putting them together in different patterns to make the construction possible. So, increasingly we start reducing the size of the stone blocks, making it easier to handle by workers on the site, so that we can actually impart the same characteristic, for the same time we cut down the size. Okay? Even many of our temples and old forts, you can see that the stone blocks that have been used are fairly large, and those are called dimension stones. Now, for that to be possible, you should have a very good source of the stone available, where you can actually extract these stones in such large sizes. However, as these stone quarries become more and more used or utilized, you can't really find large chunks of such huge blocks of stone available. So, you need to work with smaller blocks and dress them to size before using them in construction. So, how do you decide on what type of stone to use? Okay. There are various factors that govern the choice of a particular stone for construction. First is the mineralogy of the rock. What is the type, the geological type of the rock? Is it a granite? Is it a limestone? Is it a quartzite? Is it a sandstone? Okay. Now, for obvious reasons, you will also restrict the usage of the stone to what is available in the local area, right? For example, if you are down in the south, in most cases you will get granite quite easily available. If you are in Andhra Pradesh or in Tamil Nadu, you will see a lot of granite being used for the large monumental structures. If you go to Kerala, as I said earlier, laterite is quite popular. Okay. So, the availability is a primary deciding factor for using a particular type of stone. But nevertheless, you also have to be worried about the engineering properties that are made possible by the specific mineralogy of the rock. Okay. The other mechanical properties and resistance to weathering obviously are performance related aspects, and those are absolutely important to ensure that you are able to build a structure that is going to last for a long time. Okay. So, we call that as durability, strength and durability, or in the case of rocks and stones we call it mechanical properties and resistance to weathering. Okay. So, for instance, when our forefathers built these large temples and monuments, they wanted the structure to be used for number of generations. Okay. They did not think about the structure only lasting for 50 to 100 years or within their lifetimes. They built these structures to last for hundreds of thousands of years. Now, in such cases, they selected these blocks very carefully and ensured that they got the best possible blocks that were available. And of course, in those days, most of these structures were built at the whims of the king, and if the king had sufficient funds or he could bring in material from a nearby kingdom which had been annexed, They could also use a different type of stone in those days. But today, of course, a lot of the economic considerations require us to be using a lot more of the locally available materials. In fact, if you really look at sustainability also, it's always more sustainable to use what is locally available rather than source the material from outside. Because locally available materials are attuned to the specific environment that you have in a particular area. Okay? If you build in materials, bring in materials from outside, they may not survive to the same extent. The same thing is true with vegetation also, right? We try to get all these beautiful plants from all over the country and put it in our gardens. Very many of them don't survive. And a few of them that actually survive kill off the plants that were local because they are fighting for the same nutrients from the soil. So, one needs to be careful in choosing plants. At the same time, one needs to be careful in choosing materials for construction. Locally available materials are always the best for constructing in a particular region. But as an engineer, you still need to look at the material properties, mechanical properties, resistance to weathering before deciding whether the material is suitable to be used or not. Okay. Now, typically in India, you will see large amount of structures made with granite. Okay. Especially in southern India, a lot of structures are made with granite. You also have marble. Again, marble is a popular material available in the northern parts of our country like Rajasthan. You get a lot of marble from Rajasthan and it's popularly used for construction all over the country. Okay. Especially again, monumental structures like temples are often built with marble. Forts and historic monuments, a lot of them are actually made with red sandstone. Again, highly available in the northern parts of the country. A lot of red sandstone is also utilized for making many of these historic monuments. Now, these stones obviously have to be dressed to the right size, and most often this dressing is done at the quarry itself. Wherever you are extracting the stone, that is where you are dressing it. Now, there are reasons for doing this. Why would you want to do this? Why don't you simply bring it to the job site and then do it? First and foremost, when you start dressing it at the right size, you reduce the weight of the block that you have to carry to the job site. Okay? So, when you are doing dressing, that means you are cutting and shaping it, you are reducing the weight to be brought to the job site. So, that is a major advantage. So, one aspect is you are reducing the weight. The other aspect is that these stones in the quarries, often you will find that they'll be wet. The stones are wet. And it's much easier to dress the wet stones than it is to dress dry stones. Why is it wet? Because the soil water, the groundwater basically would have been seeped in through the stone and made it wet. Mostly the stones of the quarry will be wet and you can actually dress the stones a lot more easier as compared to after getting to the job sites when they've all become dry. Okay. Now, depending upon the type of aesthetics that you demand from the stone surface, you can get different types of finishes, like the rock face finish, where the outer surface, even if it's a nice cuboidal block, the outer surface, like for example what is shown here, the outer surface still looks like the rough surface of a rock. Okay. You may have a punched or a hammer dressed face also. Take a hammer and simply dress the top surface. That means you have some sort of a punched face just to give a different aesthetic appearance and so on. Okay. Again, it's imperative that the stones that you get for construction should be free of defects. Now, very often marble is something that is prone to a lot of defects. Many metamorphic rocks like marble are prone to defects because they are formed under conditions of high temperature and pressure, and very often in such cases there is a lot of moisture migration that happens from these materials. So, in such cases what you end up forming are materials with very large cavities or vesicles, and those can often form defects in your material. Even in marble, many of you may have seen, those of you who have marble flooring in your homes would see that some pieces of marble look very nice and uniform in color, whereas in others there are a lot of streaks. These streaks are obviously other minerals that are present in the marble, but very often you find that along these streaks you also get cracks in the marble because of the differential performance of the marble and the material in the streak. Sometimes you also see very large cavities on the surface of the marble. So, you need to be very careful in choosing stone for building applications. They have to be free of defects. Okay, so now what do we need to identify whether a particular stone is good for construction or not? Once again, the Indian standard has been devised to help us out in this regard. So, there are standards within this group of standards in IS 1121 parts 1 to 4, which talk about determination of strength properties of natural building stones. okay, naturally available stones, how to determine the strength, what type of size, what type of orientation you need to have for your specimen, should you test it wet or dry, all those conditions are given very clearly in these codes. And of course, not just compressive strength, but also tensile strength and shear strength determination are covered in this IS 1121. Then you have IS 1123, which basically is identification of natural building stones. Depending upon the mineralogy, depending upon the mechanical properties and so on, it gives you very clear-cut methodologies to identify what type of stone you are actually having for your construction process. And then of course, the other test parameters are water absorption, specific gravity and porosity. Those are also very important from the point of view of engineering applications of the stones. So that is covered in IS 1124. Now apart from these guiding documents, you also have documents covering individual types of stones. For example, sandstone to make slabs is covered in a very specific standards. There is a standard for laterite specifically. Okay, I think laterite standard is IS 3620. That's the laterite standard. Okay, so you need to refer to these specialized standards to tie in the specific type of stones to the kind of applications that they are intended for. But the general purpose classification of all naturally occurring stones are covered in these three standards. So once again, as I said, when you have the time and the resource available, kindly ensure that you go through these standards and the details that are presented in these standards. Now, what is the use of standards? Standards help to regularize the construction practice with a set of materials or processes, so that construction with a given material in one location is exactly the same as the construction with the same given material in another location. So the way that we select the materials, the way that we apply them in practice, right, all that should be very clear cut and easy to follow and reproducible in different locations. That's why we do standardization. Otherwise, everybody would build in their own way, right? With increasing demands of construction all over the country, we need to have processes that are standardized so that they can be repeated everywhere. So that's why we do standardization, and standards are not just for materials, they are also for processes. There are standard test methods so that you evaluate the material in the same possible way. Okay? So again, many of these test methods you will deal with during your curriculum, your regular bachelor's curriculum. You will go through those test methods, you will actually be doing them yourself in the lab, and that will give you a lot more learning than any theoretical teaching that we are actually imparting to you through these lectures. Okay? Right. Now, we have talked about brick and stone. Of course, we have not yet talked about masonry. That's a component that I will come upon a little bit later. But I wanted to touch upon the mortar materials that are typically used before that. Okay? Now, mortar is nothing but a combination of a binding material and sand. Now, what do we mean by binding material? A material that glues the sand particles together is the binding material. Now, if you use glue, that's also a binding material, right? A glue with sand will also be a mortar. But in most cases for construction, the mortar binding material typically consists of cement. Of course, you need to mix with water to make it into a binding material. You have lime, again mixed with water. Then you have gypsum. Okay. Now, gypsum itself is not used in the form of gypsum itself, but it's used in the form of anhydrite or hemihydrate, because you know gypsum is calcium sulfate dihydrate. Two molecules of water are attached in the structure of gypsum. When you take this and heat it, you get your hemihydrate, that is calcium sulfate half H2O. Right? You get calcium sulfate half H2O, basically, which is hemihydrate. And you further heat it, you get dry calcium sulfate or anhydrite. Anhydrous calcium sulfate or anhydrite. When you mix this anhydrite or this thing with water, you get back your gypsum. And that's the process of actually using a gypsum based binding material. So you have a different form of gypsum which combines with water and hardens to form gypsum. But the problem here is this gypsum also is slowly water soluble. So if you use gypsum mortar for binding in an exterior environment, what will happen is because of the moisture, this gypsum will slowly get eroded. It will slowly dissolve away, and that will lead to a very low strength of your material. So you will not get proper setting and hardening with gypsum mortars. Many of you would have done school, in your school you would have done models with plaster of Paris, right? So what is plaster of Paris? It is nothing but hemihydrate, calcium sulfate, half H2O is basically your plaster of Paris. Mix plaster of Paris with water, you get gypsum. Okay, plaster of Paris plus water gives you gypsum. Again, it is not suitable for exteriors because of moisture susceptibility. Another common material that you find in rural areas is simply the mud that they find from the soil or the clay, right? They mix it, mold it with water, make it into plastic stage and bind the blocks with that. Now, it's efficient and it's also good sustainability wise because they are using a locally available material, right? And it's also got nearly the same characteristics as the blocks that they are using with respect to thermal insulation. The problem with mud mortar or clay mortar is that it's going to be weak, right? It's going to be very weak, and again when there is a lot of wetness or moisture because of rains, it will slowly get eroded. So you need to design this mud mortar carefully, but then nevertheless you find several examples of rural structures that are using mud mortars or clay mortars to bind their blocks together. Okay, so these are common masonry materials. Again, water is present in everything because water is needed for the reactions to happen. Cement reacts with water, lime reacts with water, gypsum again it's used in other forms that need water to reconvert to gypsum and harden, and again mud needs to be molded with water. The water simply dries out, leaving the molded mud behind. That's basically the strength of your mud mortar. Okay, now one of the materials that is used extensively in India for most of our heritage monuments in the past is lime. And lime essentially was the material that was being used for thousands of years before we started using cement. Now, of course, cement was developed as an alternative to lime with a better engineering characteristic and slightly more controlled design. But lime itself remained for centuries, and even today a lot of practice for rural construction still happens with lime mortar. Now, traditionally people have started shifting away to cement mortar for residential construction and for building construction because it's a lot more stronger. But if you have to repair heritage monuments which were originally designed with lime mortar, it is always better to stick to something which is similar to the lime mortar or lime mortar itself for the repair, because that's going to be more compatible with the structure. But what is this lime? Lime basically is calcium oxide, and this is obtained from limestone, which is calcium carbonate. So when you burn calcium carbonate, you remove CO2, right? When you burn it or heat it, you get calcium oxide. CO2 is getting removed in this process and you get calcium oxide. Now please remember, whenever you burn limestone, you emit carbon dioxide into the atmosphere. So production of lime from limestone is actually a polluting process from that perspective, that it gives out CO2. Same thing you will see later with cement manufacture also, because limestone is still the primary ingredient for cement manufacture. So you still give out CO2 in cement manufacture, and indeed most of these building materials, because of their processes of burning, leave out a lot of CO2 into the atmosphere. So the building industry is actually responsible for nearly a total of 20% of CO2 emissions across the world. Now building industry means everything combined together, not just cement and lime. Okay. So what does this lime do? This calcium oxide reacts with water and forms calcium hydroxide. This process is called setting. We also know it as slaking, right? We also know it as slaking. So the combination of lime with water results in formation of hydrated lime. This calcium hydroxide is hydrated lime, and this reaction evolves a lot of heat. It's an exothermic reaction, a lot of heat is generated in this process. So if the lime has not been properly reacted with water and you use it in a structure, what may happen is it may absorb some water and start reacting inside the structure. And when it does that, the heat that is generated may result in some cracking and related failure in the structure. So you have to convert the lime completely into hydrated lime in the beginning itself before you use this in construction. Otherwise, you will have a problem. Okay? So hydrated lime is what we need for construction, not pure lime or quick lime. This is called quicklime. You have learned this in your basic school sciences, that this calcium oxide is also called quicklime, and you mix it with water, you form hydrated lime. Now this hydrated lime can be used in a mortar, so it is mixed with sand and then it is used for binding these blocks together. But how does it gain strength? The hydrated lime basically picks up the CO2 from the atmosphere and converts that, or converts itself, to calcium carbonate. Now that is very interesting. We started off from calcium carbonate to form lime, and then we hydrated the lime and carbonated it. That means it took up the atmospheric carbon dioxide and again converted back to calcium carbonate. That is very interesting. So we started with CaCO3 and we reformed CaCO3. Now, so this is the advantage with using lime. What is happening here? Although we are emitting CO2 while making the lime, we are reabsorbing the CO2 during the process of hardening. And that is a very important thing for you to remember. That is why a lot of architects prefer lime, because of this property of almost a net zero carbon dioxide emission from lime. In cement, it is not the case. You will see later that in cement, it is quite different. So as I said, most heritage monuments in India use lime as a binding material, and it is also seen that it forms an excellent bond with the brick and stone. So heritage monuments, more often than not, you are bound to find lime as a binding material or lime mortar as a binding material. Again, many people talk about this conversion of CaCO3 to CaO and then back to CaCO3 as the lime cycle. So this is a very interesting picture that is there from UK, right. So you have your limestone or calcium carbonate, which is extracted at the quarry and is burnt in the kiln, right, and you get quicklime or lump lime. This quicklime is then slaked, heat is produced because of slaking, and then you get your the lime putty. Okay, what is lime putty? So again, just to tell you this a little bit more about the slaking process. In most large lime producing facilities, what you will have is these tanks. Okay, you will have rectangular tanks. You will basically fill up with water, and then you dump your quicklime into this water. Okay. With time, if you look at what happens here, I will just draw the cross section. With time, the bottommost part, you form a nice plastic hydrated lime. Okay, all the lime gets hydrated ultimately and you form hydrated lime, but what is in the bottom is called lime putty. Lime putty has a nice plastic nature about it, and you can mix it nicely with mortar, maybe sometimes add some extra water to make your lime mortar. On top of that, you may have thinner layers of lime. You may not really have the nice thick calcium hydroxide that is needed for building construction. And on top of that, you also get what is called the milk of lime. That is almost like a white colored liquid that you get right on top. Okay. So lime water or milk of lime again can be used for your whitewashing application, for instance, right. So there are several different ways in which you can actually utilize slaked lime. The process of slaking simply is done so that all the lime gets converted to hydrated lime before the use in mortar. This is very important because the process of slaking ensures that you won't have any remnant calcium oxide left out, which will convert to calcium hydroxide later in the structure. So that is very dangerous. You want all of it to get converted to hydrated lime in the slaking tank itself. So that is called a slaking tank. Now interestingly, what has also been found is that the slaking tank results in, or rather the prolonged exposure of this lime inside the slaking tank results in very different qualities of the lime that you get for mortar making. So generally they say for plastering purposes, when you want a very fine texture to be imparted for plastering, the lime that you get has to be slaked for a long time, nearly 6 months sometimes. For binding of blocks together, the lime mortar does not need that kind of a texture. So there you can actually slake for 1 to 3 months itself. Okay. So again, as I said, architects like lime for mortar because of net carbon emission being very low, not zero, it can't be zero, but it is very low. Okay. So the CO2 that is emitted during burning, most of it gets reabsorbed during the process of hardening. it has a milky white color. Pure lime mortar will have a milky white color, and that's very good for pigmentation. You can color it in different pigments. So that's why architects like lime mortar that way. And then again, generally when lime plaster is used, you get improved thermal comfort as opposed to cement plaster because of the lower thermal conductivity. Okay. So again, there are websites which are dedicated to the use of lime, especially with lime being used in heritage monuments. Please look at this website and you can learn a lot more about the different Scottish lime kilns that are described here. It's very interesting to read that. Okay. Okay. Now, not all slaking practices are perfectly optimal. In some cases, people just dump the lime on the floor, mix the water into it and continuously mix it for a long time until all the heat dissipates. So, it depends on how the lime slaking practice is done at the site. Okay. So, once you mix it up with sand and make the mortar, it has to be in the hydrated lime form.